Here's another example. We have a uniform disk on the floor. And that's the center of mass. Let's call that contact point P. And we have a couple of forces acting on it. Let's say we have force F1 acting here, force F2 acting here, and let's say this is the radius R, and of course this is the diameter 2R. Okay, so what's the premise of the problem? A uniform disk of mass m, radius R, being pulled by forces F1 and F2 as shown. The disk rolls without slip. On the floor. And then you're asked to determine A, the acceleration of point G, B, the friction force, at point P. Okay, so this is an important kind of a problem. Okay, what's the first step? The first step is always draw the free body diagram. So let's draw the free body diagram. That's a circle. That's point G. We have point P. Let me just use a different color for the forces. We've got the normal reaction N at that point. And then we have a friction force, small f, let's say, and we do not know the direction of the friction force. But thankfully, if a disk rolls without slip, we do not need to know the direction. We just stick in whatever direction that we like, and then we solve for the friction force, and whether it is positive or negative when you solve for it determines the direction. So you do not need to know the direction beforehand if the object rolls without slip. Okay. Here's the force F1, and here is the force F2. Okay. Okay, so that's the free body diagram. I suppose we also have the mass mg acting at point G. Okay, so what do you do next? To find, we really have just a couple of principles. Again, we have F equals ma, and then we have sum of moments about a particular point, specifically G equals I alpha, and then if it's a different point, you have to have this R cross ma term. Okay, let's try to find all these quantities. Okay, so for this problem, we may need to use all those equations, specifically sum of moments equals I alpha, as well as sum of forces equals ma, because we've been asked both about the force as well as the acceleration. Okay, let's just go systematically. First of all, as soon as you see rolls without slip, you can write out a relationship between the angular acceleration or the angular velocity and the linear acceleration or the linear velocity. Okay, so recall, oops. So if you have the object like this and you have AG like this and alpha like this, or if you have VG like this and omega like this, recall from earlier that if you say VP, so this is point P, right? So rolling without slip means VP equals 0 equals VGI plus omega K cross minus RJ. This is basically RP with respect to G. And that gives you VG plus R omega I, and that's equal to 0. This implies VG equals minus R omega or AG equals minus R alpha. Okay, so this is rolling without slip. Implies this thing. Okay, so this is, let's call this equation number 1. Now let's do sum of forces equals ma. Let's do vertical. Sum of forces equals ma along the j direction. So where we are calling this to be the j direction and this to be the I direction. In the j direction, we have n minus mg equals, well, what is the acceleration in the j direction? It's actually equal to 0 because the disk is not moving up or down. So really we have n equals mg. Okay, that's actually not very useful for this problem, but we have it. Let's do sum of forces equals ma along the I direction. In the I direction, the acceleration we've denoted to be ag. So what are all the forces? It's capital F1, capital F2, the friction force small f, and that's about it. Those are the 3 forces. Okay, so let's say F1 plus F2 plus F equals mass times acceleration g. Okay, so that's equation number 3. Now we can do sum of moments equals I alpha. If you're doing sum of forces equals ma about some of these points, you can do sum of moments equals I alpha either about G or P. It doesn't matter really. You can solve for everything you need. Let's try sum of forces equals sum of moment equals I alpha about the point G. Okay, so let's do that. So let's do sum of moments about G equals Ig alpha in the K direction. What is sum of moments about G? So we have F times the moment arm R. So we have F times R. It's anti-clockwise. It's anti-clockwise, so it's in the direction K. This force F1 passes right through G, so has no moment. This force F2, its moment arm about G is R, so, and it's clockwise, so it's going to be minus F2 R. Okay. And like I said, F1 is just multiplied with 0. It doesn't have a moment. And those are the things that have moments. The other forces, N and mg, pass through G, so they don't make a contribution. So that's the sum of all moments. That's the left-hand side of this equation. On the right-hand side is just Ig alpha K. For a uniform disk, Ig is mr squared by 2 alpha K. Okay, so let's write it like that. Canceling R and the K, we get F minus F2 equals mr divided by 2 alpha. Depending on what we want to solve, we can replace alpha with A or A with alpha. So we already know that R alpha is AG, so use 1 and 4. Well, actually, before we do that, let's count the number of variables and the number of unknowns. What are the unknowns? The unknowns are Ag, alpha, the friction force F, which is an unknown. It is not equal to mu times N. And let's see, and the normal reaction N. Okay, so the unknowns are Ag, alpha, the friction force F, and N. Note, for rolling without slip, the friction force is not equal to mu k times N, but is determined by solving equations 1 to 4. This is analogous to static friction, okay, of a block. So if you have a block sitting on a table and you ask the question, what is the force, friction force on this block on a table which is not moving? It is not equal to mu times n, mu k times n. It is whatever it needs to be to prevent the block from slipping, right? So if you're pushing on a block and the block is not moving, the friction force is not mu times n, rather it is equal to whatever force with which you're pushing, and the friction force is basically exactly canceling that. Solving for equations 1 to 4 is kind of analogous to that, analogous to essentially static friction, okay? The maximum value of F such that the disk doesn't slip is mu s times n. Okay. So in other words, so if you want to see whether a disk slips or not, whether a wheel slips or not, essentially assume that it rolls without slip, compute the friction force based on those assumptions, essentially by solving for equations 1 to 4, and then see if that quantity, whatever that quantity may be, is greater than or less than mu s times n. If it is less than mu s times n, then everything is fine. The object does not slip. If it is greater than mu s times n, the object starts slipping. That's how you determine whether something is slipping or not. In any case, for this problem, we've just been told that it's rolling without slip. So we just go with that. We just need to solve equations 1 to 4. So that's pretty straightforward. Let's use equation 1 in equation 4. Equation 4 has an R alpha. Equation 1 has an R alpha. Let's plug in R alpha equals minus AG in equation 4. So let me do that. Use 1 in 4. So we get F minus F2 equals M by 2 R alpha, and then we just said R alpha is minus AG. So we have F minus F2 equals minus MAG over 2. Let's call this equation number 5. Equation number 3 has F1 plus F2 plus F equals MAG. That's equation number 3. So we can do either 5 minus 3 or 3 minus 5. So let's do minus minus. So we have F minus F2. So this is basically 5 minus 3. F minus F2 minus F1 minus F2 minus F equals minus M AG over 2 minus M AG. The F gets cancelled, and we are left with minus 2F2 minus F1 equals minus 3M AG over 2, or AG equals, I guess we can sort of remove all the minus signs, so you get AG equals 2 over 3 M goes to the denominator, 2F1 plus F2. So this is part A, answer to part A. And then we can quickly compute the value of the friction force using, say, equation number 5 or whichever equation. So let's call this 6. Use 6 and 5 to get F equals F2 minus MAG by 2 equals F2 minus whatever this quantity is, M by 2, 2 by 3M, 2F1 plus F2. So we have this expression. Okay, so that's the friction force, which is some expression involving all the other forces on the object. That's that's the friction force, that's the acceleration, the angular acceleration alpha if we need it. So this would be answer to B. Angular acceleration would be essentially minus a g over r from equation number one. And that's pretty straightforward here, which is just going to be equal to minus 2 over 3mr 2f1 plus f2. Okay, so that's going to be your alpha. Not officially asked for, but we can compute it if necessary. Okay, so that's how you compute the friction force for an object not rolling without slip. So for an object rolling without slip, do not use friction force equals mu k times n. Rather, you just set up all the equations that you need to set up, namely sum of forces equals 0, sum of moments equals 0, and then also use the kinematic relationship that embodies rolling without slip, which is going to be something like this, which is going to involve some kind of relationship between the acceleration and the angular acceleration, and then you solve for the friction force and you get some answer, and that's how you do it. I guess that's it.